So the continuous growth formula is where we often see the base E show up. So when we compound continuously, or the number of compounds becomes infinite, if we take a look at our original growth rate formula, n equals start times 1 plus the rate over n, so we divide up the rate over the number of times we use that rate over that period, and then we multiply the time by n. So this expression changes to, so that basically the green part of that expression, as n becomes infinite, the green part of that expression ends up being e. Okay, so that's essentially how we generate e. In fact, there is a limit, and you don't need to know this, but we'll learn this later. So as n goes to infinity of 1 plus 1 over n, this becomes e. Okay, and there's a reason why this happens, but we won't get into that until we get more into calculus, but essentially that's the case. So we end up with this new expression. This new expression is the one that we're going to use for continuous growth. And we almost always use continuous growth because everything can be modeled with continuous growth. So how do we use this formula? So a bank account is compounded continuously. So when we see this, we can use this formula. Okay, so basically we are trying to find the end amount. The starting value is $1,000. So this is where we use the E. So we use E. It's 5% per year, compounded continuously. So we use our rate as 0.05. Okay, and then our years, the 3 years, is times 3, or our time. So this then becomes our continuous growth rate expression. So we then just apply this expression. So we have 1,000 e to the power 0.05 times 3. So that 0.05 ends up being our continuous growth rate, the continuous growth rate. So we end up with $1,161.83. Okay, so at 5% per year, compounded continuously, we're going to end up with $161 of interest. So here we have another continuous growth problem. So when we see continuous growth rate, we know that we're going to use the formula n equals start, e to the rt, where r is our continuous growth rate. So in this case, so we want to find out the end amount. We start with our initial population of 120. E, our growth rate is 10%, and we're going to do this for 22 years. So once we set it up, all it is just typing it into our calculator to do the growth rate. So we end up with, if we start with 120 and it grows at 10% per year for 22 years, we're going to end with 1,083 people, or 0.00. Okay, so it's going to grow to that population in 22 years based on a continually compounding rate of 10%.